Lesson 5, I will decompose unit fractions using area models to show equivalence. So in Lesson 4, we decomposed unit fractions, but we were using tape diagrams, and we were showing equivalence by decomposing each unit fraction into smaller fractions. What we're going to do today is very similar, except instead of it being a tape diagram, it's going to be called an area model. It's going to look very similar to a tape diagram, and I will show you the difference in just a second. All right, so the first thing you're going to need is you're going to need to go ahead and get out your math journal. Go ahead and write today's date, and I want you to write Lesson 5, Equivalent Fractions. We're going to be drawing 2 area models in your math journal today. So I want to make sure that when you're drawing these that you leave room to do 2 of them. All right, the first thing I want you to do is I want you to draw an area model. And as you can see, this area model looks very similar to a tape diagram, doesn't it? As a matter of fact, it's exactly like a tape diagram. I want you to go ahead and in your journal draw this tape diagram or area model, and I want you to partition it into 5 equal parts, and I want you to shade one of them. Beside it, I want you to write what fractional part is shaded. Okay, so hopefully you took the time to go ahead and draw this area model, divide it into fifths and shade one of them. Make sure that you labeled the whole, and then beside it you should have written what fraction is shaded. Hopefully you wrote 1/5. It's okay if you wrote it 1/5 as a fraction, that would be fine. Right now, we decomposed tape diagrams yesterday into smaller parts. Well, when you use an area model, the difference is instead of drawing vertical lines, which we would have to draw 1, 2, 3, 4, 5 vertical lines, we're going to draw a horizontal line. So we're going to draw one horizontal line all the way across. And I want you to think about what just happened. Instead of having 5 equal parts, now we have 10 equal parts. So besides your tape diagram, I want you to write how many tenths are shaded. Hopefully you put 2 tenths. And again, it's okay if you wrote this as 2/10 instead of 2 tenths. All right, even though the parts changed, did the area covered by the shaded region change? No, it's still the same amount shaded. All we did was just break it down into 2 parts. So what do we know about 1/5? And this says 1/10, but it should say 2 tenths. What do we know about 1/5 and 2 tenths? I want you to write your answer as an addition sentence. Okay? Hopefully this is what you came up with. 1/5 equals 1/10 plus 1/10, which equals 2 tenths. The parentheses are around these just to show that this is the same amount as 1/5. So 1/5 could be changed into 1/10 plus 1/10, which together can be made 2 tenths. All right, we're going to try one more area model in our math journals, and then we're going to get right to our problem set. I want you to draw an area model that is partitioned into 3 equal parts, and I want you to shade one of them. If the entire figure represents the whole, what fraction is shaded? Pause the video, draw your area model, write what fraction is shaded, and then come back. Okay, hopefully you drew this area model and you divided it into 3 parts and you shaded one of them and you wrote 1/3. Again, it's okay if you wrote 1/3 as a fraction. Now I want you to think to yourself, if you want to take these thirds and you wanted to show that this 1/3 was equal to 4/12, how many horizontal lines would it take to decompose this third into 4/12? Well, let's think about that. If we put 1 horizontal line, instead of thirds, we'll have 6s. If we put 2 horizontal lines, instead of thirds, we will have 9ths. If we put 3 horizontal lines, we will have 12ths. So that's what I want you to do. I want you to draw 3 horizontal lines in your thirds, changing this from thirds to 12ths. All right, so how many parts do we have now? Now we have 12. How many 12ths are shaded? 4. So we have 1/3 is what we started with, and now we have 4/12. Represent the decomposition of 1/3 as the sum of unit fractions. So you're going to say 1/3 is equal to how many 12ths, basically. I want you to write this in your math journal. I want you to write 1/3 equals 1/12 plus 1/12 plus 1/12 plus 1/12 equals 4/12, because we have 1, 2, 3, 4 12ths, and that's how many 12ths it takes to equal 1/3. Now we're going to change this into a multiplication sentence because writing them as a sum of unit fractions can get really long. So underneath your sum of unit fractions, I want you to write this as a multiplication sentence. So we've got 1/3 equals, and instead of 1/12 4 times, we're going to say 4 times 1/12, which equals 4/12. So 1/3 is equal to 4/12. All right, we're going to practice some of this in our problem set. So I want you to go ahead and write your name on your problem set, and then let's take a look at the directions. Draw horizontal lines to decompose each rectangle into the number of rows as indicated. Use the model to give the shaded area as both a sum of unit fractions and a multiplication sentence. All right, so you can see they did part of this one for you. So we've got 2 rows, and we have, before we had 1, 2, 3, 4. Before we had 1/4. So up here, we're going to label this 1/4. And then when we drew this horizontal line, 1/4 became 2/8. So 1/4 is equal to 2/8. 1/4 equals 1/8 plus 1/8, which equals 2/8, or 1/4 equals 2 times 1/8, which equals 2/8. Okay, so let's take a look at B. So it says here that we have to divide this into 2 rows. So we're going to do pretty much exactly like they did before. So first of all, we have 1 out of 1, 2, 3, 4, 5. So up here, we're going to label this 1/5. And then we're going to draw 1 horizontal line. So now instead of 1/5, I have 2 what? I have 2/10. I have 2 out of 10. So let's write that. 2/10. So we'll do just like they did at the top. 1/5 equals 2/10 because 1/5 equals 1/10 plus 1/10, which equals 2/10, or 1/5 equals 2 times 1/10, which equals 2/10. All right, so let's take a look at C. This time we're going to divide it into 4 rows. We're beginning with what fraction? 1/3. Now we're going to divide this into 4 rows. So one line divides it into 2 rows. Now I'm going to divide each of these in half. So now I've got 3 rows, 4 rows. So now instead of 1/3, I've got 1, 2, 3, 4 out of 4, 8, 12. Out of 12. If you counted every one of these, you would count 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have 4/12. So we have 1/3 equals 4/12 because 1/3 equals 1/12 plus 1/12 plus 1/12 plus 1/12, which equals 4/12. A faster way to write that would be 1/3 equals 4 times 1/12, which equals 4/12. So here we wrote it as a sum of unit fractions because we added and we used these unit fractions, and this is the same sentence using multiplication. You'll notice the multiplication is a little bit faster. All right, so now we're going to draw area models to show the decompositions represented by the number sentences below. Represent the decomposition as a sum of unit fractions and as a multiplication sentence. So the first thing I'm going to do is I'm going to draw my area model. Now you'll notice the difference between an area model and a tape diagram is that tape diagrams usually look like pieces of tape. They're long and skinny. But an area model can kind of get taller, have a little bit more of a squarish look to it. So I'm going to draw this a little different than I would a tape diagram. So it says 1/2. So the first thing I'm going to do is I'm going to draw a vertical line, and I'm going to divide it into half. Now this is not going to be a dotted line, this is going to be a solid line. I'm going to divide it into half, and I'm going to shade half. I want you to do the same. So remember, when you shade, you want to shade lightly so that you don't cover up your pencil line so that you can still see where you've divided it. All right, so now I have 1/2. So it says that I need to divide this into sixes. So if I draw one line, I'm going to have 4 parts. So that's not going to work. So I'm going to have to use 2 lines. So this is divided into 4 parts. And now when I do that again, it divides it into 6 parts. So now I've got 1, 2, 3, 4, 5, 6. So here I have 1/2. And here I have 3 sixes. All right, so there's my area model. Now I'm going to represent it as a decomposition of a sum of unit fractions and as a multiplication sentence. So we're pretty much doing the same thing that we did in part 1. So 1/2 equals 3 sixes. So now I'm going to write it as a sum of unit fractions. 1/2 equals 1/6 plus 1/6 plus 1/6 equals 3 sixes. So here's my sum I'm adding, and here's my unit fractions. Now I'm going to write it as a multiplication sentence. Equals 3 times 1/6, which equals 3 sixes. Okay, so now let's try B. So again, we're going to draw an area model. Try to make it nice and neat, because the messier it is, the harder it's going to be for you to be able to see what you're doing and to be able to label it. If you make a mess, it's going to be hard to count boxes. All right, so I'm going to go ahead and divide it in half just like I did last time. Notice I left a little bit more room at the top this time because I'm trying to give some room for me to be able to label. All right, now it says to divide this. Excuse me. Now it says to divide this into eighths. So if I divide it like this, it's going to be into fourths. If I divide it again, I'm going to have sixes. So I've got to divide each of these into 3 parts. I'm going to go ahead and do that. Oops, that was supposed to be a dotted line. All right, so let me try this again. I don't think it's going to let me. All right, I'll just use my pen. All right, so let's come back and let's do 1, 2, 3. So 3 dotted lines makes 1, 2, 3, 4, 5, 6, 7, 8 parts. And I forgot to shade, didn't I? I got so hung up on how many lines I was going to draw. All right, so here's a half. And now I've taken that half and I've divided it into 4/8. So let's go ahead and label this. It started out as 1 out of 2. And now it is 4 out of 8. So 1/2 equals 4/8. So why don't you pause the video and see if you can write this as a sum of unit fractions and as a multiplication sentence, just like we did over here. If you make a mistake, it's okay. You can always erase. Okay, so as a sum of unit fractions, it would be 1/2 equals 1/8 plus 1/8 plus 1/8 plus 1/8 equals 4/8. As a multiplication sentence, it would be 1/2 equals 4 times 1/8 equals 4/8. Okay, so now let's take a look at C. All right, so we're going to do 1/2 equals 5/10. So let's go ahead and start with our area model. We're going to draw this a little bit tall. Why don't you take a minute to go ahead and pause the video and just see how much of this you can do all by yourself, and then come back and we'll work through it together. Okay, so hopefully you pause the video and you try to do as much of this as you can. The first thing I'm going to do is divide it in half, and hopefully that's what you chose to do too. And then I'm going to go ahead and shade 1/2, just like I've been doing. I'm going to lightly shade. I'm not going to spend a lot of time coloring the half. I just want to make sure that it's clear that half of it is shaded. So now I have to divide these into tenths. So that means I'm going to take each part and divide it into 5 parts. So that's going to mean 4 lines. So I'm going to do 1, 2, 3, 4. And notice that I try to keep these as even as possible. My lines aren't perfectly straight, but now let's count and see if we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have 10 parts. So I started out with 1/2, and now I have 5 out of 10, or 5/10. So let's go ahead and write this as a sum of unit fractions. All right, so here's my sum of unit fractions equals 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 equals 5/10. And as a multiplication sentence, which is so much easier to write, 5 times 1/10 equals 5/10. Okay, so if you haven't been brave enough to try to do one by yourself, why don't you try to do this last one by yourself? The worst thing that happens is you have to press play because you get stuck and you don't know what to do. So go ahead and pause it and do as much of it as you can by yourself and then come back. All right, so the first thing we're going to do is we're going to divide this into thirds. So I'm going to take my straight lines so they look nice and straight, and let's divide this into thirds. Okay, so there's one line, there's two lines. They're not exactly perfect, but it's close enough. Okay, so I'm going to shade 1 out of 3 to make this 1/3. So let's shade 1/3. And then I have to make these sixes. So if I already have 3 and I want to have 6, that means all I have to do is just divide it in half. And now I will have 6 pieces. 1, 2, 3, 4, 5, 6. So it started out 1 out of 3, and now I have 2 out of 6. So 1/3 equals 2 sixes. 1/3 equals 1 6 plus 1 6, which equals 2 sixes. And as a multiplication sentence, 1/3 equals 2 times 1 6, which equals 2 sixes. All right. Now, we're going to do 2 more. We're going to do 1/3 is equal to 4/12. So let's go ahead and draw our area model. And we're going to make this thirds again. So I'm going to divide this into 3 parts using 2 lines. Again, if you feel comfortable doing this by yourself, I want you to pause the video, do as much of it as you can, and then you can come back and just watch. All right, so I'm going to shade, oops, that wasn't right, was it? All right, let's try that again. So now I'm going to shade 1/3. Let's go ahead and label this 1/3, or let's go ahead and see. Okay, so I've got 3 parts and I want 12. So that means that I'm going to go from 1 out of 3 to 4 out of 12. So I'm going to divide this into 4 parts. So I've got 1, that's 2 parts, 3 parts, 4 parts. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I started with 1 out of 3, and now I have 4 out of 12. So 1/3 equals 4/12. As a sum of unit fractions, 1/3 equals 1/12 plus 1/12 plus 1/12 plus 1/12, which equals 4/12. As a multiplication sentence, 1/3 equals 4 times 1/12, which equals 4/12. Okay, so let's do one more area model. And this time, I'm going to make mine a little bit longer because it says fourths. So I'm going to divide it in half. This will be halves. That's not exactly half, but it's close. Then I'm going to divide each half in half. So now I have 4 parts. I'm going to shade 1 out of 4. Okay, so I'm going to take these fourths and I'm going to turn them into 12ths. So that means that I have to divide each of these into 3 parts. So that means I'm going to draw 2 lines. So I've got 1, 2 lines. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I started with 1 out of 4, and now I have 3 out of 12. So 1/4 equals 3/12. As a sum of unit fractions, that would be 1/4 equals 1/12 plus 1/12 plus 1/12, which equals 3/12. And as a multiplication sentence, 1/4 equals 3 times 1/12, which equals 3/12. All right, now it says explain why 1/12 plus 1/12 plus 1/12 is the same as 1/4. I want you to stop and think about that for a minute. Why are they the same? Okay, so we just modeled this. We just modeled that 1/4 is equal to 1/12 plus 1/12 plus 1/12 equals 3/12. So we don't need to draw a model again. If we didn't already have this model, the best way to explain this might be just to show a model. But since we already have a model, we can refer to it. So let's just say in the area model, 1/12 plus, let me write this. In the area model, 1/12 plus 1/12 plus 1/12 has the same area as 1/4. So the fractions are equal. So we had to explain why these were the same. Well, they're the same because we didn't add any more. All we did was just take them and break them into smaller parts. All right, so this was finding equivalent fractions by decomposing unit fractions. So when you get ready to do your exit slip, I want you to come back and double check your problem set and use as much as you can to help you with any areas that you're not sure about.